All right, so starting off, right, we're calculating the standard deviation of the mean. I am doing it on the TI calculator. I've keyed them into this list. After I key them into the list, what's the next step? I hit second mode to quit out of this list, to get back over here to the main screen where Blinky is, right? Good old Blinky. We're going to go on the screen here and then follow the directions to calculate the next part, which is the stat button right here. And then this time we're going to go not to edit because the number's already in the list. We're going to go over to the right, go over to calculate. It's the very first one, 1var stats, and make sure it is on L1 where I typed my numbers into the list, and I go down to calculate and press enter. And then, well, that's pretty much it, isn't it? I have an X bar. Remember, X bar is your mean. X bar is your mean, and X bar is your mean for your sample, right? It is for your sample. By the way, I'm pulling it from this one from your notes if you want to write it down. I'll put this back up in a second here, but this is where I'm going to write down my answers here. So I'm going to write down for Los Angeles, for LA, right? The mean that we got was 26.25 repeating, 26.25 repeating. You could write it as 0.255555. You could write it as 0.26. I will accept both answers. If you just write it as 0.25, I will accept that as well. If you write it as 0.56, I will accept that as well, right? If you really want to be perfect, right? That line right there shows that it repeats itself forever. But if you wanted to round it, I would love it if you rounded to 4 decimal places, like so, if you were to round it, right? But for now, I'm going to take that as that answer. That's my mean. And it looks like a lot of you guys were able to calculate the mean. Awesome job. Lewis, that's a very interesting drawing that you got going on there with your mean. But you got the same mean as me. That's good. Let's keep going there. Wow, Calvin, that is... The answer is impressive, and so is your drawing in that case. That is a very impressive drawing. Jared is angry and upset at something. Giselle, nice answer right there for your mean. And I also see your standard deviation. And Mariah, same to you. Very nice standard deviation. But let's take a look here. Which standard deviation do you take? There's a 6.1, and then there's a 5.76, right? And the key word in this problem is the word sample. And hopefully you remember, for the sample standard deviation, we take the one that looks like an S. That's all it is. We take the one that looks like an S. And the S in this case is 6.1112. 6.1112. If you write it down as 6.11, I'll take that answer. If you write it down as 6.111, I'll take that answer. If you take it down as 6.111, and if you round it correctly, that should not be a 2. That should be a 3, because the number following that 2 is an 8, and that would round up. If you wrote down that the standard deviation is 5.7618, for example, that is not completely wrong. That's just the standard deviation of the population. But what we're dealing with is not a population, and I would actually give you partial credit if you wrote down that one. But you see the symbol there, the symbol is a sigma. The sigma is for a population, where S is for the sample. So please make sure you pay attention to the problem that they tell you. And in this particular case, they use the word, or I use the word sample, right? So that's that right there, guys. How do you feel? You guys all right? If you haven't done so already, can you type in your answers into the Pear Deck, even though I already shared my answers with it? It is my way of recording your participation for the day. And I just went on a whole meeting yesterday about how do we get kids to participate more. Well, I don't know. I just give you guys credit for doing the Pear Deck. And if you don't do the Pear Deck, I just don't give you participation credit, right? That's just the easiest way that I do it, to make sure that you are participating. And I get a good amount of you guys participating, right? You remember that? I got you guys type it out into the chat too. I have that recorded as well for those of you who aren't able to get into the Pear Deck. All right. Anyways, that's the first problem, right? That's for, and by the way, in your notes was to calculate it for Los Angeles. And then can you guys do the same thing for Long Beach, right? Do the same thing for Long Beach. So I'm going to change the slide over right now. So hopefully you're finished with the slide that you're on. And I'm going to change over to slide 2. I'm going to change over to slide 2. Okay. Slide 2 has these numbers right here. Calculate the sample annual salaries for Long Beach, which is the second set of numbers right here. So I'll put it on the screen, but I'll also switch the Pear Deck over so you guys can have it on your own screen. But for Long Beach, right? For Long Beach, I want you to find the sample mean for that one and the standard deviation for that one as well. I'll put it on there so you guys can start typing or writing in your answers on there on the Pear Deck as well. So let's go ahead and switch that over. Oh, Brenda's writing an answer in there. I'm going to switch this open so you guys can change it on your own. I'm changing it to student pace right now. So if you guys could click on the next slide on the Pear Deck if you're done with the first slide. So it is open now to for you to switch slides on your own. Right? You don't need me to switch it, so you can switch it yourself. Go to slide 2. Type in your answer for this one. These are the same. It's the same question: sample, standard deviation, and the mean. But new numbers, 29, 20.9, and all that so forth, right there. So go ahead. You guys a minute. Or 2. I'm going to do this together right here. I'm going to type the numbers out myself, and then we'll follow along afterwards. When you guys are ready for a break? You guys are ready for a break? You guys? I know like we actually haven't like been in school, but we've been doing school stuff online. Even though it's online, it's still exhausting, I feel. I can only imagine for you guys. Right? It's already difficult to do work, yet now they're having you do work like this. You guys are going to get a break soon. All right, you guys are going to get a break soon. I know that you will. It's not next week. Next week is 2 through 6, which, by the way, is voting day. Make sure you, if you're 18, you go out there and vote. If you're not 18 yet, make sure your parents go out there and vote. But after next week, after election day, which is somewhere over here, I think it's November 3rd, the following week, November 11th, we get that day off. Veterans Day. We get November 11th off. So that Wednesday is going to be off for us. So yay. Right? I believe we get that Wednesday off. Or is it like a Monday or a Friday so they make it a 3-day weekend? I don't actually know. Let's click the school website. Show all events. Let's go to November. What day do we have off in November? So November 9th is going to be an even block schedule. And November 11th, Veterans Day holiday. So yeah, no school on the 11th. So if we can just make it there, right? If we can just make it there, we're going to get that day off. And then what's nice is after that day off, we can make it a couple more weeks, right? 2 more weeks. We will have Thanksgiving Day. All right, we get a minimum day on November 20th, and then Thanksgiving week. Actually, we get a whole week off for Thanksgiving. I don't know if you guys know that. You guys should know that, right? You've been at Lawndale for a while now. You get the whole week off for Thanksgiving. And I can't wait. You get a whole week off. It's gonna be great, right? It's gonna be great. Whew. All right, sorry. Back to the screen. Slide 2. Hopefully you guys are on there and you're getting the answers on there for slide 2. They should give us Monday and Tuesday off. I mean, for Thanksgiving, you're getting Monday, Tuesday, and Wednesday off. Most schools, most companies for Thanksgiving only get Thursday, Friday off. All right. Just wait until you get out of high school, guys, and you get a job. You realize, like, oh man, Thanksgiving is only going to be Thursday for some of you guys. It sucks, but it is what it is. Okay, looking at the mean and the standard deviation, it looks like some of you guys are already done. Right, that looks right. I don't know if that's right, but that looks right. I don't actually have any answers for this. Do you like corn? The best. I'm gonna come back when you're done writing, Lewis. Best meta. Oh, best metal. Oh. I haven't listened to Korn in a very long time. I was surprised to hear that they're still making music. Calvin, that's a nice panda. That is a panda, right? Okay, you got the same answer as Mariah for the standard deviation. So I'm assuming that might be right. Jared got the same as well. So did Giselle. And Michael's still working on it. They sold. Yeah, they are. I had their CDs when I was in high school, if you know what CDs are. Never bought an album, but I mean, never bought like a record, but had their CDs. CDs are cool. It was how we used to play music back in the day. We had these CD players. You had to buy CDs of these bands, and you pop them in. You have little headphones. You still own CDs? Oh, that's cool. I don't think they have, like, I don't think they release CDs anymore, though, right? Like for new bands anymore. Like that just, I feel like that would be out of date. Yes, they do. I thought some do. Oh, yeah, mostly for sure. I know for sure they still release records because there's people who collect records. I don't know if you ever seen like a vinyl record, but everything online now. Yeah, I feel like most people just, for music nowadays, you guys just get subscriptions, right? Like you guys go onto like Spotify, I'm assuming, and get a subscription with Spotify and just listen to all your music there. I don't actually know people who buy music anymore. Like that was the next thing that everyone was like trying to do, was buy all the music off of like the Play Store or the Apple Store, right? For Apple Music or whatever they use. Anyways, I digress. Let's go ahead and take a look at this problem right here on, where is my, did I lose my Google Sheets? Oh no, it's over here. It's on my other screen. So I typed in the numbers already, right? I typed in the numbers. Okay, if you want to use Google Sheet, let's go to a metal concert and do some mosh pit. I'm too old, Lewis. I'm not gonna lie. I am too old to get into a mosh pit. I will break. But also with the whole COVID thing, I don't really want to touch people. But if you want to go when they start back up, you know, you should. You definitely should. Any of you guys who have never been to a concert before, go to a concert, go to different things, experience different things. Okay? It's actually really fun. Go out there and have fun when you get the chance. Okay, let's actually move on here. So the other way of doing this whole standard deviation and mean, instead of using the TI calculator, right, you could follow these steps over here and do it on Google Sheets. And again, these are directions that I have on my notes, and they're all posted online, and I really, really, really suggest that you write them down somewhere, right? Anywhere, right? Copy it down. Follow the rules, or follow these directions, and you'll be able to calculate these things and get easy points on my quizzes and on my tests. Your next quiz that you're going to take in my class, you are going to be asked to calculate the standard deviation and not just measure if something is kind of far or hella far, right? You're also going to have to calculate what is the standard deviation. So then you can say that data is hella far from the mean, right? So let's take a look at this one right here. On these Google Sheets, I have the numbers typed into this list that I have right here from A1 all the way down to A9. And to calculate the standard deviation, I have it in quotes right here. The equation is simply, and I just type this in, equals, right? Don't type it in with the quotes. I have the quotes there just so we can see it. So it types in equals STD EV, but then dot, and this is the important part. Do you use a dot P? Let's say hella again. I'm gonna put in quotes, Michael, with the word hella, very, very far, right? Was that the one we agreed with? Was it very, very, or very, very a lot, or much a lot? I already forgot the word. But I think with my second period, we were talking about it yesterday. What was I talking with you guys yesterday? I think it was like very, very. Did we agree on very, very? Or is this very much? No, very much doesn't roll. I don't know. Very super many. Yeah. I'm saying, I think hella just rolls off of your tongue better. And I still guarantee it, if you go to your college professor and he's talking about your college statistics professor, if you ask them about 3 standard deviations and use the word hella, they're going to be okay with it. I think they will. All right. By the way, this is a .s problem. Why is it .s instead of .p? .p would be for population. .s is for your sample, right? So I'm doing it for my sample. Put the parentheses there, and then tell it where should it start looking for your numbers. It should start looking at A1. Do you see that? And as soon as you type in A1, you know you've done it correctly because it highlights it as a color, and it highlights the box as the same color as the number you typed. It's going to go from A1 all the way down to A. Notice if you type in A, it just highlights all the way down, but I wanted to stop at A9, right? I wanted to stop at A9. Press enter, right? And the equation I typed again, it's the same equation, except it's not A1 to A24 this time, it's A1 to A9 of the standard deviation of my sample, and it is going to be 2.952023788. If you write down 2.95, I'll give you the points. If you write down 2.9, I'm a little upset, but you know, it's close enough. But 2.95 would be ideal. 2.952 would be the best answer I would write down for the standard deviation. And again, this is for my sample standard deviation for the city of Long Beach, So I see that this is going to be 2.952, right? 2.952. And that's just from that. Again, get yourself comfortable with either using Google Sheets or the TI calculator. You need to get yourself comfortable with it. And if you don't feel comfortable with it, practice with this. There's nothing you can do on Google Sheets that will ever cause your computer to explode. Like, there's nothing. You can't mess this up so badly that, oh God, you broke Google Sheets for everybody. That's impossible. So just get in there and try it. There's nothing bad that can happen if you mess with Google Sheets, right? Just get in there and try it, okay? For the mean, they can't actually type in the word mean, because if you type some equals and then mean, nothing shows up. We have to find out that the mean is another word for the word average. Average, right there. You type in average, hit tab, or type in average and then put in the parentheses, and it's the same process. Tell it where it's at. It's from A1 all the way down to A, in this case, 9, not 24 this time. Press enter, and I get this calculator right here. I think it was this class. Was it this class? I think someone asked, do I prefer the TI calculator or Google Sheets? And I'm still going to stand by it. They're the same to me. I say they're both the same amount of work. But I think what some students were annoyed with is having to type in multiple equations to find multiple answers, where the TI calculator, you do it one time and it groups it all in here, including sample standard deviation compared to population standard deviation. It has it all grouped into one. So again, I leave that choice up to you. Which one do you prefer? If you were doing a free response question, by the way, on a test, and you needed to show work, all you have to do is screenshot this, right? All you have to do is screenshot this. So you hit the buttons that you had before, screenshot what you need to, right? Go into your work and then simply just paste it in there for me, right? And that would be your work. That's it, right? For these problems. Oh, by the way, the average here is not 26.25. That's the wrong problem. That's for Los Angeles. For this one, I would screenshot this as my work. Bam. Go into my notes. Type it in here. This is for Long Beach. Wow, this thing takes up a lot of space. Whoop. This one right here is for Long Beach. And I'd say the average was what, 22.87 repeating? 22.87 repeating. Or if you want to write it as 22.8888 or 778, all those are fine as well. So we've done the first part somewhat. We found the standard deviation and we found the mean, right? But you know what we haven't found was in your notes, they actually asked for a little bit more. They're also asking for the range and the variance. So this is what I want. Can you guys go back into your notes right now? Put the Pear Deck on hold and write down these values onto here. Good job, by the way, for those of you who did turn in the Pear Deck with your answers. Mariah, I'm speaking to you. Carwin, I'm speaking to you. Lewis, I'm speaking to you. Even though you only gave me the mean, that's still not bad. Get the standard deviation down as well, Lewis. That looks good. Do you like Deftones? I need to hear a song from them. I know who they are. I just don't remember their song. Calvin, good job. Hella cute. I mean, you're not wrong. That panda is hella cute. Let's see here. Giselle, good job. Thank you for typing it in there. Christina, good job. Thank you for typing it in there. You're still going with the mean. Awesome work. Jared, beautiful work. Thank you for typing that in. Michael, beautiful work. Brenda, awesome job. You're finishing up with the standard deviation. Patricia, I appreciate that. Thank you for that. And Kevin, thank you for that. I'm just going through the answers that I see on the Pear Deck and thanking all of the students who were kind enough to do their work in there and show their answers in there for me, because it makes it so like I'm not just talking to no one. That's all, Mariah. I was just thanking you for your work. All right. So after that, what we've done was those two warm-up problems, right? Those two warm-up problems, by the way, was actually your notes. It's actually your notes problem. So if you want to go into your notes right now, go into your 2.4 notes and continue where we left off. We finished off last time over here where we did the office rental rates. We're now into here with the annual salaries right here. And I have the average salary that a worker makes in Los Angeles compared to an average salary that a worker makes in Long Beach, which is not very much, is it? Not very much. They have a difference between about 4,000 here. The average at Long Beach is 22,000. The average at Los Angeles is 26,000, right? But they have larger standard deviations, right? This standard deviation is a standard deviation of about 2.9. This has a standard deviation of about 6.1. What I want to show you right now, right? What I want to show you right now is once you get these values, right? Once you get these values, you can actually calculate the variance fairly easy, fairly easy. And let me show you what I mean. So remember the symbols here. X bar represents your mean. That's what that represents. S represents your standard deviation. That's what this means. Your variance, the symbol for your variance is S with a little 2 on it. That's what variance means. And if you look at that, that little 2 just means squared. It just means squared. So if you have your standard deviation and I ask you to find the variance for me, all you need to do is take the number that's there with the S and square it. What does that mean to square it? You go to your calculator, you type in the number that's in question, which is, in this case, 6.1113, and you simply hit the little square button right here above the 7, or diagonally from the 7. You see that little square right there? Boom. So the variance is just 6.1113 squared. That's all the variance is. And I square that, I type that into my calculator, I press enter, and I get my new answer of 37.3479. 37.35. Let's round it. Let's start rounding things. So that's how you find variance, right? That is how you find variance. That's this guy right here. My highlighter is still acting stupid. I don't know if you guys can see this, but when I draw my highlighter and I pull it to the side, it like shoots a beam from where my pen is. It's kind of cool to look at, but at the same time, very annoying. Very annoying. All right, so yeah, that's how you calculate the variance. So let's do it again for this problem over here for Long Beach. What's the variance going to be for Long Beach then? Well, all we got to do is take the number that we got for our standard deviation, which is 2.952, and square it. And that's going to give me my answer. So this one over here for the variance for Long Beach is 2.952 squared. And again, how do you hit that little squared button? There's a little x squared right here. You can't see my cursor that way. It's right here next to the 7, right? My nose is acting disgusting. So yeah, hit that squared, press enter. I get a variance of 8.714. 8.714. So the data for Long Beach, right, doesn't vary as much as it does for LA, right? It doesn't vary as much for LA. Oh, by the way, that's for variance, standard deviation. How do you calculate range? Do you guys remember how to calculate range? You guys know? What do we do to calculate range? Is that easy or hard? What do you do? How hard is range? What do you think? Big number versus small number. That's right. I like how you spelled small. Yeah. So for Los Angeles, we look for the biggest number there. What's the biggest number for Los Angeles? I'm going to go with 35.9. What's the smallest number there? 18? 18.3? Is that right? I don't think there's anything who's making less than 18.3. Wow, that person's making a little bit of money. For working for Los Angeles, you think they'd be making more money. So the range here is going to be that 35.9 minus 18.3. Has a range of 17,600. And whereas Long Beach's range is, what's the largest number here for Long Beach? I think the largest number is 26.9. No one else is making any higher. And the lowest amount paid is 18.2. I would subtract those two, 26.9 minus 18.2. That's going to give me a range of 8.7. There's all my data there. There's all the stuff I have. And then looking at that, we're supposed to make a some type of interpretation that you have here. And that's kind of the big part of statistics, right? Aside from knowing how to find all these numbers and calculating these numbers, the next step is actually understanding what those numbers are telling us, right? And that's a little bit harder to do because sometimes they don't tell us much. But just looking at the average, right? You can see which state or which city has a higher paying average, right? And you guys would hopefully agree with me that LA has a higher paying average because the average for LA is 26,000, whereas the average for Long Beach is 22,000, right? But with that being said, is it better to work in LA compared to Long Beach? And that depends, right? That depends. If you're working a lower paying job, you might want to work at Long Beach because they have a lower average, but their standard deviation is smaller. So you'll be closer to the average, right? Meaning if you're within 2 standard deviations, you're still making at about, I don't know, 18,000. But for Los Angeles, if you're on a low paying job, if you're 2 standard deviations below, you might be making less than 20,000. You might be making about 14,000 because you would take this average and you subtract the standard deviation at least twice to see how far down you can go, right? You wouldn't go 3 standard deviations because that's hella far, but 2 standard deviations is kind of far and it's actually within reason. And what am I saying? What am I saying with all this here? Don't write this part down, but for Long Beach, if you are making a below average wage and you subtract the standard deviation, but you subtract it twice, right? You subtract it twice because that's 1 standard deviation and that's 2 standard deviations. What I'm saying is, how far down would you go if you're working a job that pays less? Well, let's take a look here. 22.87 minus 2.952. And then do it again. Right? And that's about 16,000. That sounds terrible, but you know, that's within 2 standard deviations of the average. Now, if you do the same thing for Los Angeles, right? This company who makes this municipal court that makes 26,025 as the average. This is a lot higher, but look at the standard deviation. The standard deviation is 6.1113, right? And again, if you subtract that twice, right, you can see that you actually go a lot further than you would for Long Beach, right? Than you would go for Long Beach. So 26.25 minus 6.1113, and you do that again, minus 6.1113. You see that the lowest paying job right there would be around 14,000, which is a lot less than the 6. Well, I mean, about 2,000 less than the 16. Again, how would I decide where to work? Hopefully, you wouldn't be making on the low end anyways, right? You'd be making on the higher end, so you guys wouldn't even consider this. So you could be making more money if you worked the Long Beach one, the LA one, because the standard deviation works both ways, right? It doesn't only work at the low end, but it also works at the above average end as well. So if you feel yourself as a hot shot that you're going to be making more money than the average anyways, you might want to consider working at LA because then you'll make way more than the average if you're doing better because they have that chance because they have a higher standard deviation, right? That's the bigger thing that helps us to measure that out. All right. Are you guys okay? Does that seem like weird to you or like confusing? Because if it does, don't feel bad. I think it is kind of confusing, but if it's not confusing, that's awesome because you kind of get the idea of what we do with standard deviation, right? It's just this tool. That's all it is. Just think of that number. It's just a tool to help you to measure, right? It's like a ruler pretty much, but it's a ruler that measures numbers, in large groups. Give me a second. I'm gonna blow my nose because this is driving me a little insane. think it's a good thing that we're not in class, because if I was like having a runny nose like this in class, it'd be disgusting. Right? We're all trying to like not spread germs to each other. And if I was in the classroom with my runny nose, it'd be a little bit gross. Ugh. Yeah, I think it's just allergies, Giselle. I don't know what it is, but whenever I come into this room, I always get like, my eyes get a little watery, and my nose is running a little bit. I should just take some allergy medicine, but I think I'm okay. I think I'm okay. But yeah, it's not feeling too bad. It's just straight up I think it's just allergies in here. Like I said, my eyes get watery when I come into this room, and my nose starts to run a little bit. All right, let's keep going with your notes, guys. Let's keep going with your notes. Okay. So I'm gonna put this one as a poll. So instead of answering on the Pear Deck for this next one, I'm gonna have you guys answer as a poll on the Google Meet, right? So in the Google Meet, do you guys see the little button with the triangle, square, and the circle, right? I'm gonna put it as a poll here for this next one, and you're gonna vote which company is better, right? From which company are you more likely to get 33,000 or more from? And we'll talk about the reasoning afterwards. But for right now, right, which company would you more likely get $33,000 from? Are we going to go with company A or company B? Go ahead and launch that. The poll is open, so if you guys want to go in there and vote. But I'm going to read this problem. You are applying for jobs at two companies. Company A offers starting salaries with an average of $31,000 and a standard deviation of $1,000. Company B offers starting salaries at $31,000 as well, but they offer it with a standard deviation of $5,000. From which company are you more likely to get an offer of $33,000 or more? And explain your reasoning. I already have someone who voted, and they chose option B for company B. Explain your reasoning. So take a minute, go ahead and decide which one would you go with. That would give you a better option or a better chance at getting $33,000 for your starting salary. Which one would you think? Would company A be the easier chance or company B? All right. Let's go ahead and show the results so you guys can keep it going there. Keep it going there. You guys are at 4 votes out of a class of, there's 35 of you guys. So if you guys are having trouble finding it, right, click at the top of the screen. There's the chat with everyone button, right? There's the show everyone button. Right next to it, there is a activities button that says, it looks like a triangle, a square, and a circle. When you click on that, it'll take you to some options that you should see there. Just click on polls, and then you guys can vote. Oh, there's 5 of you who voted already. 5 of you who voted already. Whew. Eat this last halls. Seven votes. Nice. We're getting up there. Nice. So, company A, you guys still have a chance to vote. So get in there and vote if you haven't. I have 7 votes so far out of 35 of you. There should be way more in there. Just pick one, A or B. I'm not asking you to tell me why. Let's go in there and vote. Because you are going to have to at least try that part, and then we'll talk about why one is going to have a better option than the other together. I wrote that down wrong. There we go. Good. You got up to about 9 voters. Got up to about 9 voters. Does anyone want to type out why they picked one company over the other? I'm not going to force you to turn on your mic or turn on your camera or anything like that to answer. All right. In person, you would actually raise your hand and talk out loud. I'm not going to ask all that. Instead, if you want, does anyone want to type out why they chose one company to be more likely to get a $33,000 offer compared to another? I'll wait a little bit. Because I'll be honest with you, I can explain it to you, but I feel like you might be tired of me just giving you the answers. And if not, you should be tired of me just giving you the answers, right? I know there's somebody that's like, what do you mean? You're the teacher. You should just give me the answers. It's not the easiest way to learn this topic is what I'm trying to say. You composing your own thoughts, and even if they're wrong, gives you a better chance of learning this topic. This is a really weird thing to discuss. It's not the same as your other math classes, right? We're not doing like x plus 3 is equal to 5. I'm asking you to break down why is it more likely to get offered $33,000 or more compared to from one company to another. And I want to hear, what do you think? Right? Why do you think company A is going to be more likely, or why is company B going to be more likely? I'll give you guys a minute. I really would like to see someone type out something. And I promise you, I will not, don't worry about being wrong. Don't worry about being right. Just, what do you think? What do you honestly observe? What makes you believe that one would be more likely to pay $33,000 or more compared to another company?
Company B just offers a better sample than Company A.
Okay. Better sample what? Sample. I think you're on the right track.
The averages are the same.
Mm-hmm.
Just $31,000.
Good.
But chances of getting paid better is with Company B instead of Company A.
Ah, okay. So you're looking at this second value, and it does start off with the word sample, because you're right. That is a S, right? But it's a sample. My highlighter's all over the place. Thank you, Jared, by the way. I appreciate it. It is a sample standard deviation, right? It's the sample standard deviation. And that's what we focus on, right? That's how much it is to measure if something is close or if something is far, right? So on company B, right, if I add a standard deviation of 5,000, right, this is one standard deviation, right, that gives me a range, not a range, it goes up one standard deviation away, which is 36,000, which is not very far away. Carwin's answering company B because the gaps between pay is larger, meaning you could get paid more than 33K, but it could go both ways. You're right. That's beautiful. Yeah, it could also go 5,000 in the opposite direction, right? But we're focusing on $33,000 or more. And if you compare this right here, one standard deviation away, to one standard deviation away from this value, which is 31,000 plus 1,000, you're not even getting to 33,000. You're only getting to 32,000, right? So in order to get to the next one, you have to add another 1,000, which is a second standard deviation, which only gets you to exactly 33,000, and it doesn't even get the more part. You see that? This is one standard deviation away. It's 33,000 or more. It's already more than that, and it's only one standard deviation away. Whereas this one, you're 2 standard deviations away, and you're still not even at the more part. You're just at 33,000, right? So thank you, Jared. Thank you, Carwin, for answering that. And that's pretty much it, right? You just have to take into account, what's the standard deviation in here, right? And what do you do with that number? I know there's more in your notes down here, but I want to follow up with this question right here. Let me ask you this. Let's say you're going to buy, that's a good example. You're going out to buy a new battery for your car, right? There's 2 batteries that you're looking at. There's battery A, and then there's battery B. Both are the same price, right? Both are the same price. They cost the same, right? And they both fit into your car. They both have an average lifespan, right? Average lifespan of 5 years. Okay? But here's what you do know, though. Battery A has a standard deviation of, let's say, has a standard deviation of 3 months. Has a standard deviation of 3 months. Whereas battery B has a standard deviation of 12 months. Okay. Now you are asked to pick which battery would you pick for your car. Would you go with battery A, which has an average of 5 years, or battery B, which also has an average of 5 years, taking into account the standard deviation? They both cost the same. That is correct. The only difference is this standard deviation. Which battery would you pick? Would you go with battery A? Or would you go with battery B? Which battery would you pick? Calvin's saying battery A. Do you have a reason why? And thank you, by the way, for just telling me your answer. Carwin's going with A as well. And Calvin's going with the word more reliable. More reliable. See, here's the deal, right? On this one, you can see that you can go to a higher value, right? But it works both ways, as Carwin said earlier. This one looks like it would be better, wouldn't it? Because with a standard deviation of 12, this thing could last an additional 12 months, right? It can go more than 12 months. So this could go up to 6. So in between 5, it could go up to 6 years, right? Heck, if you're lucky, it might even go to 7, right? But it also goes in the other direction as well. You could risk losing 12 months. So it can go, it's common for it to go down to 4 years as well, or even 3, right? That's within 2 standard deviations below, and this is 2 standard deviations above, because you want it to last more. And that's the common mistake, by the way. A lot of people will pick battery B because they'll see, oh, plus 12 months is a possibility for you to go higher. But it can also go lower. Yeah, you're taking the chance if you go with option B. And if you take this chance, you might go lower. Whereas if you pick option A, that's true. 5 years here. If you only go this way, it only goes 5 years and 3 months, right? 5 years and 3 months. Or 5 years and 6 months, which doesn't sound great on the higher end, but it's really good for the lower end, because if you go down to lower end, the lowest it can go really is about 4 months, 4 years and 6 months, right? If you go 2 standard deviations below, whereas this one you could lose all the way down to 3 years. This is only going to be to 4 years, 4 years and 6 months. It won't be as much as 3 years, right? So battery A would actually be the better one. It's more reliable, smaller standard deviation, right? More reliable values for that one. So just to keep that in mind, right? Sometimes you want a higher standard deviation. Sometimes you want a smaller standard deviation. If I was, like I said, if I was comparing your test scores to test scores in period 2, right? And I was trying to give that free pizza party to whoever did better, but you guys had the same average, I would then start to look at the standard deviation. So if you had a better standard deviation than period 2, then you guys would be considered the better score. Yeah, that's exactly it. Even if period 2 had one kid who got like a perfect, but their standard deviation is huge and their average is the same as your average, I would still go with your class. Okay? I'm just lying, by the way. We don't have pizza parties in my class. Well, also, we're not in person. I can't actually get you a pizza party. How unsanitary would that be, though? Right? If you think about it now, right? You get like a gigantic pizza box, and then one person like opens it, and everybody has to take a slice, and you're reaching into this box. And if you're like last, you're reaching into a box that everybody else has touched. Anyways, make it a tradition. Nah. Thought about it, but it just doesn't work out. Food in the classroom always ends up like, it's always a mess. And I'm always the one who has to clean it up. It's no fun. I can deliver it to you. Technically true. I could stop by and deliver you guys a slice of pizza. That sounds good right now. I want some Costco pizza. Maybe I'll go get some Costco pizza for lunch today. Anyways, let's keep going. Let's start talking. Let's keep going here, right? Compare the three data sets without calculating. Determine which data set has the greatest sample standard deviation and which one has the least sample standard deviation. So these are two problems, by the way. Don't mix them up into one problem, right? So looking at this, right? Hopefully you guys can see the larger your standard deviation, the more your data spreads out, right? The more your data spreads out. So I'd say right here for number one, this one right here, this one has the largest standard deviation, right? Largest standard deviation. And that's because the data is, wait, no, that I lied. Not that one. It would be this one. I'd say that one has the largest standard deviation because the data is more spread out, right? The data is more spread out. This one actually is a little bit closer together, but it's not as clumped as this one. This one has the smallest standard deviation. Okay? Because all your data is very clumped together. You see that? It's close together. So when you have your standard deviation, by the way, if you don't have the standard deviation and you only have the numbers there, you can actually tell which one is the larger standard deviation based off of how spread out your data looks. All right, look at this one. This one right here. This one has the smallest standard deviation as well. And how do I know that without actually looking or calculating the numbers? Well, look at the numbers. They're all clumped together around 1, 2, and 3. This one looks like it's almost clumped the same, but there's a couple numbers that are outside, which are like this 9 and this 41, right? So this is not the smallest standard deviation, but it has a smaller standard deviation than this one. Do you see this number right here? These numbers are more spread out than either one of these. So this one right here would be the largest standard deviation. Okay? Are you guys okay with that? Like understanding what standard deviation is yet? Like you see that it's a tool that helps you measure stuff, right? That's all the standard deviation does. It measures how far away you are from the average. But not only that, it helps you measure the graph itself, right? If you have a standard deviation that's very small, your data looks like most of it is going to be around a specific mean. If your standard deviation is large, your data will look something like this, where it's still around your mean, but it's more spread out, right? It's more spread out. So just keep that in mind, right? When you're looking at data as a graph, standard deviation helps you measure like how tight is your data or how spread out is your data, right? Hopefully you guys can see that. So that's the idea behind your standard deviation and your graphs. All right. I'm going to cover this topic right here, and I'm actually going to wrap up a little early today. That's because this next part is it's a little weird. But you guys should have learned about this before. So it's nothing new, hopefully. And if it is new, it's not that bad to learn. It's the empirical rule, okay? The empirical rule. The empirical rule applies your standard deviation onto a normal curve, something that is normally distributed, right? Have you guys heard of this term before? The normal curve or the bell-shaped curve? If not, that's the most common thing that they call it, right? Is the normal curve, normal curve, or bell-shaped curve. In the bell-shaped curve, you can actually calculate or estimate the number of people who are within a specific range. And they estimate it with these percentages. If your average is here and you go 1 standard deviation above and 1 standard deviation below, you can make the claim that over half of the people, in fact, about 68% of the people are between this value. You can actually measure it. 68% are between here to here. If you go to 2 standard deviations out from the average, from here to here, you can say that there are 95% of the people who are between that. What does that mean numerically? If I asked 100 people to line up by height And if their height was the same as someone else, they would stack on top of each other. Not physically stack on top of each other. Like they'd stand here and then they'd stand behind them, right? So if you could imagine that, I'm looking down, right? And people are lining up by their heights. If I knew the standard deviation with the average height, I can say that from here to this standard deviation, I can say that out of 100 people, 95 of those people would be standing right here. That's what the 95% means. If you had 100 people, 95 people would be standing there. If I had 100 people, 68% of them would be, or 68 of them would be standing here within 1 standard deviations. Last but not least is 3 standard deviations away. And this is why I'm saying it's hella far if you go past 3 standard deviations. Because if you go to 3 standard deviations, you're now at the part where all of your data would be included, almost all of your data. You're up to 99.7. That's almost everybody from here to here. If you go past that, that means you're in the part of the 0.3% that's not included in that small that region. And what does all this mean? So let's say we're looking at the average heights. What do you guys think the average height of males are in the United States? What do you think? Any ideas? Anyone got any clues? What's the average height? 58. 58 what? 58 inches? 59. Oh, 5'9", 5'10", 5'8". Gotcha. All right. Let's Google it. Average height. Let's see here. All charts on human heights. That's a little too weird. Let's not go into that one. Average height of men in the US. Where are we at? Dog is upset at something outside. So, average height in the... Why is it everything... what? Why is it every country except for the United States? Am I not seeing it? Do you guys see it on here? Why am I seeing everything except the United States? Am I misreading this? Mexico, Nigeria, Peru, India, Philippines. Oh, average height in Philippines is very short. Average height in Netherlands is really tall. What the heck? 5'11.9". They're almost average height of 6 feet. Where's the US in this? Oh, here. 5'9". 5'9" is the average height. I'm vertically challenged at 5'7". It's not bad. So it looks like the average height in America, in the United States, is 5'9", right? You're 6'5". I don't believe it. I don't believe it. But you could be. I haven't met you in person yet. But here's why I'm bringing this up, right? If you took everybody and you had them stand on a line, right? And if they're 5'9", they'd stand right here. 5'9", right? And if another person lined up and they're 5'9", they'd be right here as well, right? So if you make a dot plot, or imagine their heads as dots on here, right? 5'9" would be there, then you do 5'10", and over here it'd be like 5'8", 5'7", 5'6", 5'4", 5'3", 5'2", and then you make these dots, right? For people who are shorter than 5'9", and for people who are taller than 5'9", 5'9", 5'10", 5'11", 6 feet, right? 6'1", 6'2", 6'3", and you would, if you measured 100 people, you'd get people who are very tall and very short. I'm 6'1". I'm like a little bit off of 6'1", like 6 foot and like half an inch, right? 6 foot and like half an inch. So I'd be like right here, right? If I was standing in this group of people, right? And if I had these people here, would you guys agree that if my average is 5'9", most of the people would be around the height of 5'9", with the exception of the people who are very tall, right? So if I had them standing and there was already a person standing there, they'd have to stand behind them, right? Like this. See that? So we'd go by heights here, and there may be a couple people. We'll go with Lewis. He's saying he's 6'5", so 6'5" would be like right here. So there's your dot, Lewis. You're right there, okay? So if you're 6'5", right, that'd be like right here. 6'5". And then there's also, of course, people who are shorter, 5'9", there's in the middle, 5'8", 5'7", right, would be right here, 5'7", right? Calvin, you're 5'8", so you'd be like right here. This would be your dot right here for 5'8". You're not that far off. You're very close to the average. And then, of course, 5'5", 5'6", 5'5", 5'4". This would be like 5'3". If you're 5'3", you'd be like right here, right? And what I'm saying is if you line up people by their height and you took 100 of them, it would look something like this, right? It would look something like this. Now, what I think is neat is if you know what the standard deviation is, right? If the standard deviation was like, let's say, 2 inches, right? That means if I go 2 inches above 5'9", which would be at 5'11", which stops here, and I go 2 inches below 5'9", which is 5'7", which is about here, I'm saying that with the empirical rule, if I had 100 people line up with me, right? If I went to 5'7" to 5'11", this number in here would be 68 out of 100. 68 out of 100, right? 68 out of 100. That's what I'm saying. So that's what that 68% represents. If you had all your data, like this is impossible to imagine, but if you could imagine like all the data you collect, have them all standing on a field somewhere, 68% of them would be between one standard deviation above and one standard deviation below. And I think that's neat because if you imagine like a billion people, you can get 68% of those billions to be grouped up in that little section right there. And if you go further, right? If you go 2 standard deviations out above and below, you actually encapsulate 95% of them. Meaning if you had 100 people, 95% of them would be in here, and the other 5% would be either really short or really tall, right? And if you go to 3 standard deviations, right, you don't say that that's 100%. You say that that is 99.7%. And even though Lewis is saying that he's 6'5", he's included in there, right? He's included in there, and that's almost everybody, right? Including someone who's very, very tall. But here's the thing: why is that not 100%? Why is that not 100%? Even though we know that 3 standard deviations away is considered very, very, very far, because of outliers. There are people who are way taller than 6'5", aren't there? And there are people who are way shorter than like 5 feet, right? Yao Ming, yeah. Yao Ming was 7'6" or something like that? He was something ridiculous. Yao Ming height. Yeah, he was 7'6", right? And that's a very unflattering picture. Ooh, okay. There we go. So yeah, these outliers, right? Yao Ming, I think that's Muggsy Bogues, by the way. Muggsy Bogues is like 5'2", who played in the NBA. He was a professional player at 5'2". But yeah, is that Muggsy Bogues? I think that's Muggsy Bogues. Anyways, what I'm trying to explain here, though, is what is this whole empirical rule thing? If you had IM1 at Lawndale, you should have learned this. And if you had IM1 with me, I forced you to remember these numbers as 68, 95, 99.7. I would say it repeatedly: 68, 95, 99.7. 68, 95, 99.7. But, ooh, excuse me. Whoa. That sneeze was terrible. But, oh, okay. Thank you, Lewis. So what I'm saying is, right, if you have this data of the average and the standard deviation, right, you now can estimate, with reasonable with reasonable numbers here, you can actually estimate how many people are between a specific height, right, or between a specific amount of money they make, between a specific whatever it is that your data is talking about. You have a way of estimating that now, and I think that's kind of cool. You know, you can actually say like, well, the average is this, and the standard deviation is that, but you're claiming to make this amount of money. You are either lying or you are, doing something that's unfair, that's giving you way more money than what everyone else should have, right? And that's what the empirical rule does. It measures where should the clump of your data be, right? And there are of course going to be outliers, like Yao Ming's height, for example, right? And that's just how it is. But you can actually measure now, and you can actually get a percentage like, oh, you're supposed to be between this range or that range. Anyways, we'll do some actual problems next time. I just wanted to share with you what the idea was behind the empirical rule. But when we actually do the calculations, you'll see like it's actually fairly easy to do when we actually do these calculations to see what percentage of people are between what height and what height. If I know the average and I know the standard deviation. So if I know what the average is and I know what the standard deviation is, I can do these calculations, right, for this right here. But we'll do that next time. Okay, it is 11:55. I did promise you that we're going to end early. This is not as early as I was hoping it would be. I was hoping to end a little bit earlier, but I guess I got on a weird rant about height. But that's okay. If you want to retake your quiz from yesterday, please stop by today during my office hours from 1 to 2. And if you want to retake any other quiz from chapter 2, just come in, let me know that you're from period 5, and let me know which quiz, the name of the quiz that you need to retake, and I can go in there and reset that for you. Okay? Other than that, guys, have a good rest of your day. I will see you during my office hours, and if I don't see you during my office hours, I'll see you on Thursday. All right? See you guys later. Have a good day. Thank you, guys. Thank you. So long. Farewell. Bye-bye.